Assalamu alaikum warahmatullah. Welcome back. In the previous two videos of the same topic, classification of quadrilaterals. Okay, this is the part third of the same topic. In the previous two video lectures, we start with the classification of quadrilaterals. We classified the quadrilaterals into three different types, three broad classes. Depending upon the fact that whether the quadrilateral have both the pairs of opposite sides parallel or one of the pairs of the opposite sides parallel or none of these opposite sides parallel, right? Okay, the three broad types that we discussed were parallelogram, number second trapezium, and number third kite. Okay, in parallelogram we observed that both the pairs of opposite sides are parallel. In trapezium only one pair of opposite sides are parallel, and in kite none. Okay, then we talked about the the various types of parallelograms. We modified the parallelogram into two different types of quadrilaterals. One was rectangle. We discussed the properties of rectangle. Then we talked about the properties of rhombus. Then we modified the rectangle and rhombus. We modified the rectangle with respect to its sides into a different type of quadrilateral, what is called a square. A square can also be formed from the rhombus when we modify the rhombus with respect to its angles. Okay, we also talked about the properties of square also. Okay, so the three broad classes were: number first, parallelogram, number second, trapezium, and number third, kite. Right. Okay, now today we are going to talk about this trapezium, right? What is this trapezium? Okay, as we already discussed that, okay, see, this is a trapezium. This is a trapezium. Okay, you can observe that in this trapezium, okay, this is a type of quadrilateral in which you can observe that this side is parallel to this side, okay, and these two opposite sides, they are not parallel. So only one pair of opposite sides is parallel. Okay, this is the definition of trapezium, right? So trapezium is different from parallelogram. In parallelogram, both the pairs, okay, I can you can see that in parallelogram, okay, this side is parallel to this and this side is parallel to this side. In parallelogram, both the pairs of opposite sides are parallel, but in case of trapezium, you can see that only one pair of opposite sides is parallel, right? Okay, now let me try to modify this trapezium. See, what I will do is that, okay, this, say for example, okay, see, let me join these two. Okay, see, this is again a trapezium in which this side is parallel to this and these two sides, but there's a difference between these two trapezium. Okay, here these non-parallel sides, okay, this side, for example, A, B, C and D, this side AD is equal to side BC. Okay, so the trapezium in which the non-parallel sides, okay, non-parallel sides in which non-parallel sides are equal, okay, that type of trapezium is called as isosceles trapezium. That's called as isosceles. Sometimes asked what is isosceles trapezium. So isosceles trapezium, okay, is the one in which the non-parallel sides are equal, right? Non-parallel sides are equal, and There are some more properties of isosceles trapezium. These base angles, okay, these base angles, that means angle ADC, this one, and angle BCD, this one, they are equal. Base angles are equal. Base angles are, when I say base angles are equal. Base angles means the angles which are formed by the larger parallel side. Those are called the base angles. Okay, so base angles are the one which are formed by the larger parallel side with two non-parallel sides. Okay, see, for example, the trapezium is now in this way. Okay, I will upside down the trapezium. Okay, we will get, still the base angles are, these two are base angles because they are formed by the larger parallel side. These are the base angles. In isosceles trapezium, base angles are equal. Okay, this is again an important property of isosceles trapezium. Then there is one more thing. If I join non-consecutive vertices, okay, I get the line segment BD and line segment AC. You can see that these two diagonals, okay, these two diagonals in an isosceles trapezium, the diagonals are equal. The number second is diagonals are equal, although they do not bisect each other. Okay, you can see that this part is smaller than this part and this part is smaller. They do not bisect each other, but the length of the diagonals, okay, since these sides are equal, right? So we can see these diagonals in an isosceles triangles, diagonals are equal, right? Diagonals are equal. Okay, this was about the trapezium. So trapezium is different from parallelogram in the fact that in trapezium only one pair of opposite sides is parallel as against the parallelogram in which both the pairs of opposite sides are parallel. Okay, now let's talk about the kite. Okay, see, this is a kite. I will name its vertices A, say B, C and D. So A, B, C, D is a kite. So what are the different properties of a kite? You can see that in this kite, adjacent sides are equal, consecutive sides are equal. Okay, this side is equal to this side, and BC side BC is equal to. See, in this type of a quadrilateral, none of the pairs of opposite sides are parallel. Right, is parallel. Okay, so we can say that okay, in parallelogram both the pairs of opposite sides are equal. In trapezium only one pair of opposite sides, and in kite none of the pairs of opposite sides is parallel. Okay, so इसमें कोई side parallel नहीं होता है, right? Okay, then there is one more important property of a kite. You can see that these consecutive sides are equal. AD is equal to BC and BC is equal to DC, right? Okay, then let's try to draw the join its opposite vertices to get its diagonals. Okay, this is diagonal AC and this is diagonal BD. Okay, one of the most important property of a diagonal of this kite is here, that this larger diagonal, so that means here larger diagonal is AC, larger diagonal is perpendicular bisector of B shorter diagonal. Sorry, here shorter diagonal is BD, shorter diagonal. Okay, this is the most important feature of this, the characteristic feature of kite, that this larger diagonal, it bisects the smaller diagonal. So you can see that this part of diagonal BD is equal to this part, right? Okay, and you can see that this part is smaller than this. Okay, so smaller diagonal, although it intersects this larger diagonal, but it does not bisect diagonal AC. So BD, diagonal BD, though the shorter diagonal is perpendicular on AC. Okay, but it does not bisect it, right? It does not divide it into two equal parts. But larger diagonal, what does a larger diagonal do? It bisects the smaller diagonal as well as it is perpendicular to it. So we can say that larger diagonal, not smaller diagonal, larger diagonal is perpendicular bisector of the shorter diagonal, right? Okay, let's now this finishes our this classification of quadrilaterals. Let's now revise the contents of the previous two videos. Let's have a quick revision of this classification of quadrilaterals, okay, that we discussed in the 3 videos. Okay, let's have the quick revision that what we did, we classified the quadrilaterals into 3 broad types: parallelogram, trapezium, and kite. In parallelogram, both pairs of opposite sides are parallel. In trapezium, only one of the pairs of opposite sides is parallel, and in kite, none. Okay, in parallelogram, we discuss the properties: opposite sides are equal, opposite angles are equal, diagonals bisect each other, right? In trapezium, okay, we talked about the isosceles trapezium, in which base angles are equal, diagonals are equal. Okay, in case of kite, okay, in which you can see that the adjacent sides are equal. The most important property of kite is larger diagonal is perpendicular bisector of the smaller one, that means the smaller diagonal. Okay, then what we did, we modified the parallelogram first into rectangle with respect to its angles. Okay, we modified the parallelogram into rectangle, then we modified this parallelogram into rhombus with respect to its sides, right? With respect to angles, we get the rectangle. When we modify the parallelogram with respect to its angles, we get the rectangle. When we modify the parallelogram with respect to its sides, we get a rhombus. In rectangle, we talked about the various properties. Number first was opposite sides are equal. Opposite sides are equal, right? This is the first property. Then diagonals bisect each other. Diagonals bisect each other. Okay. Then number third is diagonals are equal, right? Diagonals are equal. This is the additional property of rectangle. Okay, this is not found in the parallelograms. Diagonals are unequal in but they bisect each other, right? They do not bisect each other. Okay, now then there is they bisect. Rhombus. In rhombus, we discuss the various properties. Okay, opposite sides are equal. Opposite sides are equal. Okay, then diagonals bisect each other, second property, and the additional diagonals bisect each other, and then number third, diagonals are perpendicular. Okay, then we modified this rectangle and rhombus. When I modify rectangle with respect to the sides, I get square, and when I modify rhombus with respect to its angles, I get square. Once again, in square, what we see is that diagonals bisect each other. Okay, they bisect each other. Number second, diagonals are equal. And number third, okay, all the sides are equal. That is found in the rhombus as well. All the sides are equal. Okay, what is seen in rhombus also, and diagonals are perpendicular. Okay, this finishes our the topic classification of quadrilaterals.